Okay, let's go over the test. So, first of all, to get a handle on what this looks like, what the zeros might be, we're going to graph it. So I've already typed it into my calculator, and I think I have it right. Very important that you check and make sure that this is the correct equation that you're typing in. Otherwise, you're not going to be able to get things to work. And it looks like it is, so I'm going to push zoom 6. And there it goes. And it looks like it goes straight through at 0. Which means it has a multiplicity of 1. It goes up, it comes back down, and it bounces at 2, so that means a multiplicity of 2 because of the bounce. And it's degree 5, and I've got 3 of them. That means there's 2 left, and I don't see them, so they're probably quadratic. So I got to reduce this down to the quadratic and use the quadratic formula, or if I can, just solve it. So that's where I'm at. Now, as long as I'm looking at the graph, let's take a look at all this that I don't need to have all this on. End behavior. So it looks like it started from down below, came up, so this end is down and the other end is going up. Let's put that out of the reflection there. What else do I have here? A local minimum. If it's going up and it comes down, there's a local minimum, right? Or maximum. There's a maximum up here someplace. So I'm going to see it by going second, calculate the maximum. I'm not just going to see it, I'm going to find it. And the maximum is somewhere, left and right, somewhere between 0 and 2. So between 0 and 2, I'm going to guess 1. And it says it's at 0.75, and that's not what the maximum is. The maximum is the 13.037. 13.037. And further down, I might need to know where it's at x equal 0.751. 0.751. But I don't need that for the max. The maximum is just how high it is. And the local minimum is how low. And the low spot is 0 in that area. It happens at x equal 2. Okay? And I might need that later, but the local minimum is 0. And it only happens one place, there. That's not the local minimum because it keeps going down. Determine, oh, it was off the screen there, so it was 0 at there. Determine the intervals where the function is the y value for what x is the y less than 0. When is the y less than 0? So the y values here are less than 0. They're greater than 0 because they're above the x-axis. They come back to 0 and then they go up again. So it's less than 0 over here, equal to 0 right there, and right there. So less than 0 for x is over here, the graph. The y values are less than 0. So from negative infinity to 0, it's below, the y values are negative. That's what this is saying. Or equal to 0. So at 0 it is equal. So we want to include 0. Because the height is 0. Then from 0 to 2, it's above 0. It's positive, greater than 0. At 2, it is equal to 0 again. So we've got to go union, and at 2, from 2 to 2, it's 0 again. And then after that, it's positive, not less than 0. The y values are. And finally, when is it decreasing? Well, if I go left to right, it's going up to that place. And then it came down, so it's decreasing here, And then when it gets to 2, it starts increasing again. So from 0.751 over till 2 in the x, it was decreasing. Now I use parentheses instead of brackets because at this place it's changing from increasing to decreasing, so I don't want to include there. It's not increasing or decreasing, it's changing. And at 2, it's changing from decreasing to increasing, so I don't want to include it because it's not decreasing there. So I don't include those two places. And again, these are the x values where the y value is decreasing. The y height, the height of the curve, is decreasing between this x value and that x value. So these are always x values that we're looking at. And that's why we want to have these for down here, but we don't need them to determine max and mins. Okay, so we got all this part taken care of. But we still need to find the other two zeros here. Now, since 0 is a factor, that means x factors comes out of all this. So if I'm doing the factored form, there is an x, and if I factor this, like writing x minus 0, that's the x, and x minus 2 for the 2 twice, because of that, I'm going to only get x, and then if I multiply by the other 2, I'm only going to get x to the 5th and not 2x to the 5th, so I need a 2 because of that 2. So there's a 2 that I should put there, and this is f of x. Now, I didn't take any points off, but you should be saying the function is 2 because of the 2 leading coefficient. Everything else we're going to get down to x minus or plus the zeros. A 0 means there's an x, and the 2 means it's x minus 2, because it bounced, it's twice, and that's 1, 2, 3. We need 4 and 5, so we need 2 more that we're going to get from simplifying this. So if x pulls out of all this, like you can see, there's 5, 4, 3, 2, there's an x in every one of these, I'm going to pull it out. And what would be left is 2x to the 4th. I don't need to keep my x's to do the synthetic division, but there's 2x to the 4th minus 8x to the 3rd plus 18x squared minus 40x plus 40, taking out an x. And now if I divide by 2 synthetically, I'll reduce it to x to the 3rd. So it'll be 2x to the 3rd times 2 is 4. Add a negative 8 and we get negative 4 times 2 is negative 8, which add to 18 is 10 times 2 is 20. Add negative 40 and we get negative 20 times 2 is negative 40, comes out to have a remainder of 0. Goes in evenly. And I need to do 2 twice, so I'm going to do 2 again into what was left. Forget the remainder now. 2 plus 0 is 2. This will be 2x. This is 4, 3. This will be x squared. I'm going to be down to my quadratic after this. 2x squared, but 2 times 2 is 4. Add, I get 0 x's. Times 2 is 0. Add 10, we get plus 10. 10 times 2 is 20, and no remainder. So it went in evenly. So I've reduced my original one. I've pulled out an x, and x minus 2 twice, and I'm left with a quadratic, 2x squared plus 0x plus 10. If I pull out the 2 that you can see in here, I really have just x squared plus 5. Factoring out a 2. There's that 2. So I'm just down to this. And if I make this equal to 0. I can subtract 5. Since there's not an x term in here, x squareds and 5s, but no x term, I can subtract 5, and I get x squared equals negative 5. Take the square root of both sides, and I get x equals plus or minus the square root of negative 5. And some people mess this up, so it's plus or minus. The square root of negative is I, and the square root of 5 is, to be exact, we need to leave it the square root of 5. Only the 5 under the square root. The I is outside. So my other two zeros that make the factor 0 are plus the square root of 5 times I not under the square root, and minus the square root of 5, I, which means factored, it would be x opposite of that minus square root of 5, I, and x opposite of that plus square root of 5, I. There's completely factored. And showing how you get the exact is worth points. Okay, y-intercept. That's just, you let x be 0, and if you let x be 0, intercept's a point, so you should write it as a point. When x is 0, this whole thing works out to be 0. And you can see it on the graph. Goes through 0, 0. And that's an x-intercept too, because it's crossing the x-axis there. And it's also crossing or touching the x-axis at 2, 0. That's a double intercept, but that's an intercept and that's an intercept. Okay. We don't list the imaginary zeros because you don't see them as x-intercepts on the graph. And that's number 1. Number 2. So gravity in meters is, you use negative 4.9 times the t squared. If it's in feet, it's negative 16t squared. But we're not going to write it with a t squared. We're going to write, if it's going to, Ponder kicks it at time 0, we need to have t at 0 where it starts up at time 0. So we have an x-intercept of 0, so we write t. And if it comes back to ground at 5.4 seconds, we write t minus 5.4. So there's a parabola that will be touch at 0 and 5.4. This will be a right side up parabola because it's positive t squared. To make it be upside down, we need a negative, and we need 4.9 because it's in meters, so it's negative 4.9. And then we'd have t squared and negative 4.9 times the negative 5.4 t. And that would be the equation for the height at some time t. So, if I type that in, turn that one off, come up here and type in negative 4.9 x parenthesis x minus 5.4 close parenthesis, and go zoom 6. I see go up and come down. And it should be at 0 and at 5.4, and it looks about right. Now, how high did it get? Well, it's off the screen. I could change my window so that the y maximum was high enough to see it. Let's say this is in meters, so probably 100 meters would be enough. Let's try that graph. There it goes up and down. It didn't get anywhere near 100 meters. It's more like 40 or 50. So I changed it to 50, It's even less than 50. What's the maximum height? Now in Desmos, you could just tap it on here so I can calculate the maximum. That's somewhere between 0 and 5. And it's probably about 2. Enter, and it says at 2.7 seconds, but I don't need that because I didn't say when is it. Determine the height the meter would have to be kicked to. The height that would have to be kicked to is 35.72 meters high. So that's about 110 feet straight up. That is pretty hard to do. So if a punter's got a 5.4 second hang time, that is amazing. Okay? Determine the average velocity between 2.3 and 3 seconds. Well, velocity is change in distance over change in time, which would be the slope. Rise over run would be change in distance over change in time. The run is change in time. So I just need to find the slope between those two. So I need to find those 2 points. Where is it at 2.3 seconds? So I'm going to go second, calculate the value. This is the easy way to do it on the calculator. Second, calculate the value at 2.3, and it's at a height of 34. 2.3, it's at a height of 34.937. At that many seconds. And then when it's at 3, enter, it's at 35.28. At 3 seconds, it's 35.28 meters. So it's right near the top, so it's not going to be going very much. It's going up. It's actually turned and started coming down, but its average was going up. So it's going to be a pretty small value here. And it's the slope, so we take the 35.28, got to change the change in y, so we take y2 minus y1. So 35.28 minus 34.937. So it went up 0.343 meters. Over what was the change in time? It went from 2.3 to 3, which is 3 minus 2.3 is 0.7 seconds. So its speed is 0.343 divided by 0.7. So it was going 0.49 meters per second. And it's positive because it was still going up. It went from here to there, up a little bit, positive. Now, what is the velocity of the football just before it hits the ground at 5.4? Well, let's do 5.3 and 5.4. What are the heights? So, second, calculate the value at 5.3, and it's at 2.9597. And at 5.4, it's at 0. We made it be 0. So now you could have done 5.39 and 5.4. You could have, and that would have been an even better estimate for the average velocity, but just trying to get it really close. So 5.3, 5.4 is good enough. So you can see it's going down. It went down 2.597 meters in the 0.1 seconds difference in the times I set, which turns out to be, if I divide that by 0.1, I get negative 25.97 meters per second. Now, if you chose a little bit different separations in the time, like 5.39 and 5.4, something like that, you might get slightly different, but it's going to be close to this number. It's going down pretty fast. That's number 2. Okay, complete the square. So when we did that, we had to have a 1 in front of the x squared, so we factor out the 2. So we pull the 2 out of this term and this term, we set aside the 11, and it becomes x squared minus 4x plus something minus something plus 11. And then we had to use half of that, so it's going to be 2x minus 2 squared. Half of that goes in here, but when you multiply this out, we're going to get minus 2, half of this squared, which is 4, and we add it and subtract it. So these 3 are in this, and that's times 2. This negative 4 is also in the parentheses. It's times 2, so that's negative 8 plus 11, which turns out to be 3. So we got 2 times x minus 2 squared plus 3, which means this parabola is moved plus 2 and up 3, so that's where the vertex is. And the center line then, since it's moved over plus 2, it's x equal to is the axis of symmetry or center line. And you could graph that to check and make sure you've done things right. Okay, this one. Now, some of you went on autopilot and said, okay, there's a barn on one side, I don't need to worry about that. Well, I didn't put a barn on the side this time. I have 500 feet of fencing, and I have to fence every side of this. So I could put X here, or Y here, on each of those. And I could put Y for the whole thing, or I could put Y for each separate one. I'm going to do each separate one this time. So the area of one pen would be X times Y. And for all the pens, it would be 3 times that is the area. That's what I want to maximize. So I want to graph this, but if it's got 2 variables, we're not going to be able to do that. So we need to get it down using a constraint. And we're limited to 500 feet of fencing to do all of the pens. This side, and all of those. So I've got 1, 2, 3, 4 X's to build with my fencing, and 1, 2, 3, 4, 5, 6 Y's. Now, if you chose to make the Y be the whole thing, then you'd have just 2 Y's. Now, I need to replace either the X or the Y with something from this. So I got to solve for either the X or Y. I'll choose to solve for the Y, so I'm going to subtract 4X from both sides. equals 6y, and then I'm going to divide by 6. And so I'm going to put in place of the y this. So my area is going to be 3 times x. We're not replacing it, we're replacing the y, and the y is 500 minus 4x over 6. Now I could reduce the 3 with the 6, but don't need to. I could just type it in. So that's 3x parenthesis 500 minus 4x close parenthesis divided by 6. Zoom 6 goes up, and I don't see it come down, and I don't see the maximum or anything, but this is a quadratic with a negative coefficient, so it must come down. So I need to zoom out, and I'm going to go up here a ways and over a ways, making this the center. Enter. There it goes up. Don't see it come down, so I'm going to come over and up and press enter again for zoom out. Went up. I do see it come down, so it must have a maximum up there. Right now it's going up to 200, and it looks like it's got to be a lot higher, so I'm going to do 2,000. And I'm going to mark it every 100. And now let's look at my graph. And I didn't do enough, but you can see that it's doing upside down. Let's go to 10,000, marking it every 1,000. And let's go up here and mark, since these are going in the hundreds, I'm going to mark it every 20. So now I've got 20 units each this way and hundreds this way. 100, 2, 3, 4, 5, 6, 7, about 800. And then this is tens, no, 20, 20, 40, 60. Looks like about 60 something. For the x, that makes the maximum. Second, calculate the maximum, and I can just press enter for the left bound to there, and I can move over. Now I'm on the right side, press enter, so I'm going to look between there. My guess, I'm just going to move sideways. It's about there, press enter. It says 62.5 is the x, and this is in feet, so feet is my x. So this direction is 62.5, and I got to figure out the y, which I can just use this, but this gives me the area. I don't want that. I want the y. So I'm going to quit here and go 500 minus 4 times 62.5, and I get 250 for all of the y, and I'm going to divide by 6, and that'll tell me that 41 2/3 feet is how much 1 y is. So each pen would be 62.5 feet by 41 2/3 feet. And that would be the dimensions of each pen. Determine the dimensions of the pens if the total area is maximized. So this is what I wanted. Now, we could do this a little differently here. If I simplify this, this would be a 2. So I'd have 2 goes into 500, make 250. So I'd have 250x, and 2 into here would be 2x times x, which would be minus 2x squared. And that's what this looks like. And the quadratic formula says that minus b over 2a, we will have the vertex, or I can complete the square. But this is the b, so if I do minus 250 over 2 times a, and that's a minus 2, so minus 2 times 2 is minus 4. So 250 divided by 4 is the 62.5 feet. So I could have found it by not looking at the graph and doing what we've learned before. It's moved over 62.5 feet, this parabola that's upside down. So that's how it relates to what we've been doing, this problem. Okay. Divide using long division. So I got to put 2x squared minus 5 into 6x to the third. Some of you like to leave spaces for the terms so you can line them up. I'm not too particular here. Plus 21x squared. There's no x's, so you can leave a space if you want. Minus 6, you don't have to, or you can put in plus 0x. But anyway, what do we multiply 2x squared by to get 6x to the third? Well, 2 times 3 is 6, and x squared times another x would be x to the third. So I take the 3x times this, and I get 6x to the third, and 3x times a negative 5 is a negative 15x, not x squared. So if you're lining them up, I would put it negative 15x. But you can put it underneath, I don't care. Anyway, at this point, we draw the line and change the sign so that we can add like terms. These cancel. These are not like terms, so I get 21x squared plus 15x minus 6. And what do I multiply 2x squared by to get 21x squared? I think I have to multiply by 10.5 or 10 and a half or 21 halves. So 10 and a half times 2 is 21x squared. 10 and a half times 5 is 52.5 and negative. Negative 52.5 has no x, so it goes like, if you want to line them up, it's going to be negative 52.5. I still have to draw the line, change the signs. These cancel. I get 15x, and minus 6 plus 52 is plus 46.5. And so you put your remainder, since this won't go into here anymore, can't multiply by x squared times anything to get just x, so we're done. We go plus the remainder, 15x plus 46.5 divided by my divisor, 2x squared minus 5. And it's plus in here. And that one's done. Synthetic division. If you didn't do problem one with synthetic division, it's a challenge. Here's one that it won't go into evenly, but we have to have all the coefficients. So we have 1x to the fourth minus, there's no x to the thirds, minus 3x squareds plus 2x's minus 5. We have to have them all. And when you're doing synthetic division, you divide by the 0. What makes this 0? A negative 4. So we add. 1 plus 0 is 1. We multiply. We get negative 4. We add. 0 and a negative 4 makes negative 4. We multiply. We get positive 16. We add and we get 13. We multiply, we get negative 52. We add, we get negative 50. We multiply, we get positive 200. We add, we get 195. This was x to the fourth. We're dividing by an x, which makes this x to the third. So our answer is 1x to the third minus 4x to the second plus 13x minus 50. And this is the remainder, so plus 195 over what I was dividing by. Now, you could do long division. You could do this into that, like you did up here, do long division. You should get the same answer. So if you want to check yourself. Number 7. So degree 5 polynomial means we have to have 5 zeros. We have a plus 2, a minus 2, a negative 5, and negative 1 plus 2i, that's only 4. We need one more. But if plus 2 is a 0, the factor is x minus 2. If it's plus 2, we have to add a negative 2 to get it to be 0. If it's minus 2, if x is a minus 2, it has to be plus 2 to be a 0. If it's minus 5, if x is minus 5, we'd have to add a plus 5 to be 0. If x was this, we'd have to add 1 and subtract 2i to get a 0. So you see how we're getting the opposites of everything. And if there's a complex one, it comes from the quadratic formula that says the minus b over 2a plus or minus the square root part creates the I. So it's going to be plus 2i and minus 2i. So the last one would be minus 1 minus 2i. And if x was that, it would have to be plus 1 plus 2i. And that would be a degree 5. 1, 2, 3, 4, 5 multiplied. X is multiplied. Degree 5 polynomial. Okay, this one is a degree, see that's squared, so that's x times a negative x times an x. Well, this is a negative x times a negative x, which is plus x times a negative x times an x. So it's a negative, so it's an upside down degree 4. So 4 would either be both up or both down. So this has to be both down. It crosses at, see, 3 minus x. X would have to be 3, so it crosses at 3. It actually bounces at 3. It crosses at 1 would make that 0. And there's 0. And it crosses at negative 2. So if it's starting down and crosses at negative 2 and then comes back down through 1 once, and then goes and bounces at 3, it must do something like that. And I asked for when this y value is greater than 0. Well, it's 0 here. The y's are greater than 0. It's positive. All the way to there, then it's 0 again, and then it's negative here, it's 0, and it's negative. So the only places where they're positive are between negative 2 and 1. And not at 2 and not at 1. Just here, the y values, this is the y value, is greater than 0. And finally, we have this. This is a negative 4, so that means a factor is, I'll do it up here, x plus 4. It went straight through, so it happens just once. It went through minus 2, so that means that x plus 2 is a factor. Straight through. And it looks like it not bounces, but not straight through. It looks like it hesitates at 3. So it's probably x minus 3 to the third. And then it's probably too big, and so there's probably a number to multiply by to get the function. And we have to get it to go through 0, 4 for the y-intercept. And that's how we're going to figure out the a. If I put in 0 for all the x's, I'm supposed to end up with 4. So I'm going to write 4 has to equal a times, if I put 0 in here, I get plus 4. If I put 0 in there, I get plus 2. And if I put 0 in there, I get negative 3 times itself 3 times, which is negative 27. And I need to solve for a, so I'm going to divide both sides by all 3 of those. So I'm going to get 4 divided by a 4 and a 2 and a 27, negative 27. And that's going to be a. Now the 4's cancel, so I just got negative 1 over 54. So if I replace the a with negative 1 over 54, I have the equation that makes this graph. Okay.